To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So I'm going to continue with the extra questions related to current electricity. In the previous chapter, I did MCQ type questions. That was the extra question 1. So here we have extra question 2. From here onwards, you will have to write the answers. So it would be better if you all write the answer first and then you can check your answer with my discussion. Extra question 2. First one, what are the two types of electricity? So you know the two types, static electricity and current electricity. What is static electricity? The charges deposited on the surface of an object that do not move. That is static electricity. And when a current of electrons start flowing through a conductor, then we call it the current electricity. So those are the two types. What are the two types of electricity? One, static electricity. Second one, current electricity. Then the second part of the question. Explain the above briefly. So how do you explain static electricity? You have an object, usually an insulator, and you rub that object with another material. Then there is a flow of electrons from one material to the other. The material that loses the electron, object that loses the electron becomes positively charged, and the object that gains the electrons becomes negatively charged. And these positive or negative charges do not flow. They are stationary on the surface. So that is what we call as static electricity. First we will explain that. So here matter is made of atoms that contain positively charged protons and negatively charged electrons. When an object is rubbed with a material, there is flow of electrons. The object that loses electrons gets positively charged while the object that gains electrons becomes negatively charged. Such charges deposited on the surface of a material. So usually this material is an insulator. So such charges deposited on the surface of a material is known as static electric charge or static electricity. So mainly that. We will read the explanation again. Explain the above briefly. Matter is made up of atoms that contain positively charged protons and negatively charged electrons. Here students, I have given a very elaborate, although the question says briefly, I have included all the information. If you want, you can shorten it a little bit more and write the most important points only. So here I have explained matter. Then when an object is rubbed with a material, there is flow of electrons. The object that loses electrons gets positively charged, while the object that gains electrons becomes negatively charged. Then, such charges deposited on the surface of a material, usually it is an insulator, is known as static electric charge or static electricity. I am sure you all can understand that. So in this explanation, if you like, you can leave out the initial part where I explain matter, because that is something that is known to you. So you can start from the point where I explain this. When an object is rubbed with a material. So this part is kind of optional. You can leave that out and explain. Then we need to explain current electricity. What do we do there? When there is a charge difference that leads to potential difference, there will be flow of electrons. The current of electrons that flow through a conductor is known as the current electricity. So there, if we explain current electricity, when there is a charge separation, for example, the positive and negative terminals of a cell, there will be a pressure difference that will make the electrons to flow through a conductor. What is this pressure difference known as? We call it the potential difference. This potential difference leads to an electromagnetic motive force that drives the electrons, or we can say, to be more specific, free electrons to flow. The current of electrons that flows through a conductor is known as current electricity. So here, so when there is a charge separation, for example, the positive and negative terminals of a cell. So you all know, if you take a battery, a dry cell, there is a positive terminal where there are less electrons. Positive charges are more. And at the negative terminal, there is an accumulation of electrons. That is why it becomes negatively charged. So this charge accumulation causes a pressure difference. And that leads to a driving force. That is what we call as electromotive force. So here you can see there will be a pressure difference that will make the electrons to flow through a conductor. So this potential difference leads to an electromotive force that drives the free electrons to flow. So when there is a charge separation, there is a pressure difference that leads to an electromotive force that drives the electrons to flow through a conductor due to the potential difference. So then, the current of electrons that flows through a conductor is known as current electricity. So I am sure I have recalled all what we learned before. So we have briefly explained the two types of electricity. So with that, students, I am going to move on to the next question. Extra question 3. What will happen to small pieces of rigiform when a plastic rubbed on hair is brought near them? So you take a plastic comb or plastic rod, you rub it on your hair and you hold it near tiny pieces of paper or tiny pieces of rigiform. And what will happen? Those tiny pieces of rigiform will get attracted to the plastic rod. Why is that? Because when you rub the plastic rod on your hair, there will be static electric charges formed on the rod. That is what you need to write here. So what will happen? That is the question. What will happen to small pieces of rigiform? When a plastic rod rubbed on hair is brought near them, the small pieces of rigiform will get attracted to the plastic rod. So here I have written a complete answer, students. You all can write a short answer saying that they will get attracted to the plastic rod. So I have said the small pieces of rigiform will get attracted to the plastic rod. Then, why do objects rubbed with another material attract tiny pieces of paper? So we have already answered this question before also. Due to the static electric charges present on the surface of the object that was rubbed with another material. So here we can say objects obtain static electric charges when rubbed with another material. These charges attract tiny pieces of paper. So objects obtain static electric charges when rubbed with another material. These charges attract tiny pieces of paper. So the question is, why do objects rubbed with another material attract tiny pieces of paper? So the explanation is this. I'm sure you all have written the similar answer. I'll move on to the next question. Extra question 4. What are electrical conductors? Materials that allow current electricity to flow through them easily, or allow electrons to flow through them easily. So here we can say materials that allow current of electrons to flow through them easily. That is important. If they don't let the current of electrons to flow easily, then they are not conductors. They become insulators. So materials that allow current of electrons to flow through them easily are known as electrical conductors. So that is the answer. Then the second one. Metals are good conductors of electricity. Why? Now you can remember, it's not a must to draw the diagram, but you can show it. If you take a metal like that, the atoms are there. Metals are made up of atoms. And from these atoms, the free electrons on the valence shell, the last shell, they tend to come out of the atom. They can be removed easily. So because of that, the atoms get positively charged. And there are free electrons. Electrons that were removed or that came off from these atoms are there as free electrons. Now these free electrons can move easily. These free electrons can flow through very easily. When a potential difference is applied, they are directed in a certain manner. They are directed in a certain direction. So they flow from negative terminal towards the positive terminal of the dry cell through the conductor. So that is why they become very good conductors of electricity. Why? There are free electrons present in metals. So the answer is the presence of free electrons in metals make them good conductors of electricity. Is that okay, students? The presence of free electrons in metals make them good conductors of electricity. So that is the question. Metals are good conductors of electricity. Why? So the reason is presence of free electrons. So this diagram is optional. This is for you all to understand. The answer is this. So with that, I'm going to move on to the next question. Extra question 5. How do electrons flow from a cell in a circuit? How do electrons flow? From the negative terminal of the cell to the positive terminal of the cell through the circuit. So that is what we need to write there. How do electrons flow from a cell in a circuit? Electrons flow from the negative terminal towards the positive terminal of the cell via the circuit. So from the negative to positive terminal. Electrons flow from the negative terminal towards the positive terminal of the cell via the circuit or through the circuit. Then the second one, what is the reason for the above? What is the reason? Now in the negative terminal, there is a high concentration of electrons. Amount of electrons or negative charges is very high near the negative terminal. So therefore, the negative terminal has the ability to push the electrons away. So that drives the electrons from the negative terminals when a potential difference is supplied. So that is why electrons flow from negative to positive. So what is the reason for the above? The negative terminal has the ability to repel electrons while the positive terminal attracts them. Therefore, electrons flow from negative to positive terminal. So what I explained to you all, in the negative terminal there are more electrons, so the negative charges are high. Because of that, the negative terminal has the ability to repel electrons. At the same time, positive terminal doesn't have electrons, that is why it's positive. So because of that, it has the ability to attract electrons. So when a circuit is connected, it becomes complete. Electrons tend to flow from the negative terminal towards the positive terminal. Then, how does the conventional current flow in a circuit? That is something that you know. When electrons flow from negative terminal to the positive terminal, conventional current flows from the positive terminal to the negative terminal. So here, conventional current conventional current flows from the positive terminal to the negative terminal. Conventional current flows from the positive terminal to the negative terminal of the cell through the circuit. That is important, students, because the current does not flow just from the positive terminal to the negative terminal of the battery, but it flows through the circuit. Now you can remember, we drew the circuit diagram. Let's say if there is a component there, and here if we have a bulb like that, that's the positive terminal, negative terminal. Current flows through this. Now this is for your understanding, through the circuit only. It doesn't flow from here to here, not from here to here. This is the positive terminal, this is the negative terminal. It doesn't flow from here to here. It flows from the positive terminal through the circuit towards the negative terminal. That's why it's very important. You have to understand that clearly. Conventional current flows from the positive terminal to the negative terminal of the cell through the circuit. So that's important. It flows through the circuit. Same thing goes for electrons also. When I wrote that, you can see electrons flow from the negative terminal towards the positive terminal of the cell via the circuit, through the circuit. That's important. So this is current while the electrons flow in this direction. Electrons negative to positive, whereas current positive to negative. I am sure you are familiar with that concept. So with that, students, we will move on to the next question. Extra question 6. The first one, write the letter that indicates the direction of current flow. So there is a circuit diagram given to us. You can see here, there is a dry cell. You can see the positive terminal and the negative terminals. They are labeled as A and B. Then you can see here, there is a connecting wire connected to the bulb, and that comes to the negative terminal again. And there is an arrowhead pointing this way from positive to negative direction like this, and that is indicated as X. Then there is another arrowhead from negative terminal towards the positive terminal, that is indicated as letter Y. So the question was to write the letter that indicates the direction of current flow. Current flow positive to negative through the circuit. Electron flow negative to positive. So Y is the electron flow. So X is the current flow. So write the letter that indicates the direction of current flow, X. I am sure you all have done that. Then write the letter that indicates the direction of the electron flow. Very simple, Y. So X is the current flow and Y is the electron flow. So with that, students, I'm going to move on to the next question. Extra question 7. First question, what is electromotive force? So here you all know, students. Now if we take a battery, so here we have a battery and the positive terminal. This is the negative terminal. So here there are negative charges. Here there are positive charges. So these two charges, the terminals, generate a pressure difference, electric pressure difference when they are in a circuit. That electric pressure difference is what we call as the potential difference. So here, if it is connected by a conductor, there is a pressure difference, that is the voltage or the potential difference. So as you can see here, students, there is a positive charge, positive terminal, negative charges are accumulated in the negative terminal. So because of that, there is the pressure difference, electric pressure difference, that we call as the voltage. And with this voltage difference or potential difference, when the cell is connected to a circuit and the circuit is completed, what happens? The negative terminal has the ability to repel the electrons, and positive terminals has the ability to attract the electrons. Due to this potential difference, there is a force with which the negative terminal repels or pushes the electrons into the circuit. So that force is what we call as the electromotive force. So there is a pressure difference that generates a potential difference, and due to this potential difference and the ability of the negative terminal to repel electrons, there is a force with which the negative terminal pushes the electrons into the circuit. That force is what we call as electromotive force, EMF. I'm sure you all can remember that. So then, to answer the question, what is electromotive force? The force with which the negative terminal of the cell pushes the electrons to the external circuit is known as EMF, electromotive force. So here electromotive force is EMF. The force with which the negative terminal of the cell pushes the electrons to the external circuit is known as EMF, electromotive force. Then what is potential difference? I already explained that to you all. The electrical pressure difference between the terminals of the batteries, that is known as the potential difference. So here the electrical pressure difference between the terminals of a cell is known as potential difference and or voltage. Another name, potential difference, voltage difference, all refer to the same thing. The electrical pressure difference between the terminals of a cell is known as potential difference or voltage. Then the next one. What is resistance? The ability of a material to hinder the flow of current, or the hindrance caused by the material against the flow of current. That is what is known as resistance. The ability of a material, or else you can say conductor, to oppose the flow of current is known as resistance. The resistance of a conductor tries to prevent the current flow. That is why when the resistance increases, the current decreases. So the ability of a material or a conductor to oppose the flow of current is known as resistance. So those are the questions, students. With that, I will move on to the next question. Extra question 8. Write the standard units used to measure the following quantities and the instrument used to measure them in the table given below. So here you can see the table. The first column gives the quantity, potential difference, current and resistance. And the second column is the SI unit and the instrument. So potential difference, what is the SI unit? Volts, capital V. Within brackets I will write the name also, volts. And the instrument, voltmeter. Voltmeter. Then current, amperes, A. Ampere. And what is the instrument? Ammeter. Then resistance is measured with the SI unit, ohm. This is the symbol SI unit, and instrument ohm meter. I have mentioned this before also, students. Voltmeter, ammeter, we write the words together. It's only one word. But ohm meter, you have to write it as two separate words. Ohm meter. So potential different volts, voltmeter. Current, amperes, ammeter. Resistance, ohm, ohm meter. So those are the standard units and the instruments used to measure the quantities. I am sure you all fill this table correctly. With that, we'll move on to the next question. Extra question 9. There is a diagram given to you. We'll read the explanation and look at the diagram. A nichrome wire coil, a voltmeter, an ammeter, a rheostat, a switch and 4 dry cells are connected as shown in the diagram. So you know all these things. Nichrome, normally nichrome is a conductor, a wire, but it has very high resistance. So you know when current flows through nichrome coils, there is a tendency for the coil to become hot, for the temperature to increase because of the high resistance. Then voltmeter to measure potential difference, ammeter to measure current, rheostat. We used a rheostat to change the resistance of a circuit when we did the activity to verify Ohm's law. Then a switch to turn on and off the circuit, 4 dry cells. Dry cells, they are the power source. They provide the potential difference. So now if we look at the diagram, you can see here the nichrome wire coil. Then parallel to that, the voltmeter is connected. And here you can see the 4 dry cells connected to the nichrome wire coil, and continuously you can see the rheostat here, the switch here, and the ammeter there. So those are the components of the circuit. Everything is connected there. And here you know Normally, voltmeter is connected parallel to the nichrome coil so that you can measure the potential difference across the coil. But the current flow is the same throughout the circuit. So, we have the ammeter here. So, that is the circuit. Then, the switch was closed and the readings of the voltmeter and ammeter were obtained quickly. Then the switch was turned off. So this is something that you are familiar with. When current flows through nichrome wire coil, it can get heated up. The temperature will change. When the temperature changes, the resistance of the conductor changes. So then we will not get correct readings for the voltmeter and ammeter. So you have to close the switch, that is complete the circuit, allow the current to flow. Immediately you take the readings and then you need to open the switch so that the temperature does not change. And you all know, students, when we verify the Ohm's law, it is under constant temperature. So it is very important for us to maintain the temperature of the nichrome coil. The procedure was repeated after some time. So why after some time? So you leave the circuit to cool down a bit. The coil, even if it had become hot, it would cool down a little bit. So to make the temperature constant. 5 sets of readings were taken. So by repeating that procedure, they have taken 5 sets of readings. So that is the activity. Then we look at the questions. First one. What is the function of the ammeter? To measure the current flow through the circuit. Measure the current flow through the nichrome wire coil. In brackets, I will say circuit. Now, the same current flows through the nichrome wire coil and the circuit that I told you all. Why I have written nichrome wire coil here is because the potential difference is across the nichrome wire coil. So, we want to find the relationship between potential difference and current. So, there we need the current flow through the nichrome wire coil. But the same current flows through the circuit. So that is why I changed the answer. I have written it as measure the current flow through the nichrome wire coil. Is that clear, student? So then this next question, second one. What is the function of the voltmeter to measure the potential difference across the nichrome wire coil? So measure the potential difference across the nichrome wire coil. So that is the function of the voltmeter. Normally function of the ammeter to measure current. Voltmeter to measure potential difference. But here in this activity, we have written the specific functions. So I am sure you all also wrote a similar answer. With that, we'll move on to the next question. The third part. Why is a rheostat used in the circuit? Why do we need a rheostat? To change the resistance of the circuit. To change the resistance of the circuit. So here, students, you all might be wondering, now we use the rheostat. We change the resistance of the circuit. But when we write the relationship between potential difference and current, we calculate V over R, the ratio, and then we say that is the resistance and that is a constant. But there you have to remember, students, that particular resistance is the resistance of the nichrome wire coil, not the resistance of the circuit. That is why we calculate the potential difference across this and the current flowing through the nichrome wire coil. So there, the resistance that we calculate is the resistance of the nichrome wire coil. And we verify the Ohm's law. So you have to keep that in mind, students. To change the resistance of the circuit so that you can get 5 sets of readings, because nichrome wire coil is only one component. So the resistance of that component will not change. So therefore we change the resistance of the circuit and then we get 5 sets of reading. Is that clear to you? So then, the next question, why do you need to obtain the readings quickly? Why do you need to obtain the readings quickly? So that the nichrome wire coil does not become hot, or we can say the temperature of the nichrome wire coil does not change. So that the temperature of the nichrome wire coil does not change. So why do you need to obtain the readings quickly? So that the temperature of the nichrome wire coil does not change. That is the answer to this question. So part 5. What can you say about the ratio between the voltage and current in all 5 instances? What can you say? We did the activity. It will be the same value, or you can say it will be a constant. It will be a constant. So what can you say about the ratio between the voltage and current in all 5 instances? It will be a constant. You can remember V over I, and that is what we call as resistance R. Then write the name of the scientist who discovered the relationship you mentioned in part 5 above. Who was the scientist? George Simon Ohm. George Simon Ohm. So write the name of the scientist who discovered the relationship you mentioned in part 5 above. So here the ratio between voltage and current, V over I, is a constant. That is the relationship proposed or discovered by George Simon Ohm. And what is the name given to the above relationship? What do we call it? We call it as the Ohm's law. Ohm's law. So the relationship is known as Ohm's law. So that is what we have here. We have a few more questions related to this, or actually one more question. Plot a graph to illustrate the relationship that is obtained from the activity. So we find the relationship between V and I, ratio between V and I, and that is a constant. So what is the plot? We plot voltage across against current. This is voltage V, current in amperes, or you can, instead of writing as Current, you can say I amperes. Voltage, of course, it's V, potential difference V. Then you will get the plot that goes through the point of origin. That is the relationship. Plot a graph to illustrate the relationship that is obtained from the activity. Current in x-axis, potential difference or voltage in y-axis. You will get a plot, a graph like this that goes through the point of origin. And you all know, if you get the gradient of this graph, you will get the resistance of that particular conductor, because V over I gives you the resistance. I'm sure you all can understand that. So with that, students, I will move on to the next question. Extra question 10. Write the Ohm's law. What does the Ohm's law say? At constant temperature, the potential difference is directly proportional to the current flow through a conductor. That is the Ohm's law. At constant temperature, the potential difference is directly proportional to the current flow. So write the Ohm's law. At constant temperature, the potential difference is directly proportional to the current flow. That is the Ohm's law. Then the second part, V over I is a constant. What is the name of this constant? What is the name of this constant? It is the resistance. Resistance. So V over I is a constant, and what is the name of this constant? It is resistance. So with that, students, I'm going to end this chapter, and thereafter in the next chapter also I will discuss some more extra questions with you all.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.